There are some key differences between enzymes from different manufacturers, so it's important to carefully consider the options before you start building an RPA assay. There are three factors that matter most: lot-to-lot consistency, freeze-thaw stability, and underpinning both of these is whether each enzyme has its own individual activity assay. Let's look at why these things are so critical, starting with the individual enzyme activity QC. Historically, RPA has been less popular than LAMP because results weren't reproducible. This was due to varying activity levels of the enzymes that were not quality controlled beyond a binary yes-no result for working in an RPA assay. Here's an example showing that losing only 10% of one of your active enzymes in an RPA reaction has an outsized effect on the overall amplification yield. At the limits of detection, this could make the difference between a positive and a negative result. That's why it's critical to QC each enzyme individually, and why that QC has to be done using an activity assay. Thanks to individual enzyme activity-based QC, we can ensure every batch of enzyme performs the same, and it's this consistency that is critical in getting reproducible RPA results from one lot to another. The last big consideration is whether the enzymes can withstand freezing and thawing. If reagents can't be refrozen, labs waste product or risk running out mid-study. Formulations designed for freeze-thaw stability eliminate that issue, extending reagent use and reducing waste. So when sourcing RPA enzymes, look first for whether each individual enzyme has been quality controlled using its own activity-based assay. If they have, you can have some confidence in the data you see for lot-to-lot consistency and freeze-thaw stability. If you'd like to see more RPA data or to try it yourself, visit the Watchmaker Genomics website or check out our other videos in this series.